Hi friends, welcome to Techie Study and T SQL tutorial series. In this session, we are going to discuss about exploring horizontal partitioning with creating a new partition table. So here we are going to create a large table data set, and we are doing the partition for the table. Let's see the step-by-step procedure. Horizontal partitioning, also known as range partitioning, involves dividing a table's data into multiple partitions based on ranges of values in a specified column. So we need to specify the column in a table, which is I am specifying a column here, date column we are using. So based upon the 10 years of data, we are going to create the year wise partition by year, and by using those partitions we will create a new partition table. Once we created the partition table, we will load the data from existing table, then we will rename the existing table as a backup, and we will rename with the original table as a new partition table. We will see the step-by-step procedure. Identify the partitioning key. As I said, we need to choose a column that will serve as the partitioning key. This column should have values that can be divided into ranges. Okay, so create a partition function. First we will create a function, user groups. Define a partition function that specifies the ranges. The partitioning the data, use create partition function statement to define the ranges based on the chosen partitioning key column. So create a partition scheme. Once created a partition function, then we will create a partition scheme. Create a partition scheme that maps the partition defined by partition function to file groups in the database. To create the partition scheme statement to define as a mapping. So create the partition table, next step. So once we create a new partition table with the same schema as the original table, but specify the partition scheme created in the step 3, which we have created the partition scheme that we need to mention in the newly creating partition table. So this new table will inherit the partitioning defined by the partition scheme. So populate and partitioned table, insert data new partition table by selecting from original table. Once we created a partition table, we will load the existing table data to partition table. Use appropriate partitioning key column to determine which partition each row belongs to. Okay, once we loaded the data, we can validate the data by using original table and a newly partitioned table. Once we done, we can drop the original table. It's optional. So before dropping, we require like we will create as a partitional table, right? So original table name is consider p item, G item. Okay, we will create a G new item as a partition table. So actual table name is G item, right? So we need to rename as a backup G item. G item new table we need to rename as a G item to original table. So partition table will go live into the production. So existing table we can take it as a backup, or we can delete the drop the table. Okay, let's see the examples by creating the tables. So let's create a new database. Okay, done, and use DI reporting, and we will create a table now, G item, okay, with the primary key. So this is done. Once that is done, let me create a insert the data. So G item, so 2017 to 25 we are going to insert the data with dynamically some the sample data to the table. Okay, this is the query to insert the data to the G item table. Okay, I will add these queries in Drive. I will share the link in resource description level in the video. You can download and you can practice, and whatever you can do it. Okay, so let's insert the data to the table. Start from G item. Okay, so it's executing. Once it is done, then we will check the data. Okay, it's inserted. G item table. DOB is the partition key column we are going to use. So we have data 2017 to 25. We are going to create the partitions from 2017 to 25. Okay. Now we need to create the file groups. So from 17 to 25, we are creating the file groups. Okay. Here I have created the 25 partition file groups. You can check by using this query. You can check the available file groups. See, from 17 to 25. By default, primary should be there. Whatever we have created partitions, we have available now, file groups. Okay. So now next here, whatever the path you required based upon your requirement, you can mention this path. Okay. For now, I have created C folder and partition. Okay. C folder, partition. Here you can see the nothing is there. Once we create NDF files, here we can see those files. Okay, this is the file group, creating the database files, alter database, DI reporting, add file, partition 2017. It's 2017 related data. It will store in this partition. Okay. So this is the NDF file. Let's create up to 25. Same script, but the partition names will be different. So 18, 19, 20, 21, 22, 23, 24, 25. Okay, let's go ahead and create this. Okay, we have created the partition file. See, all partition NDF files are available in this location. Okay. Once that is done, to check the added file groups, we can, by using this query, we can check the following file groups which we have created now, NDF files. See, these are the NDF files which we have created now. So actual files, this one micro SQL server MDF file is available in this location. Which we have created NDF files, we have available in this location, different path. Okay, that is done. Next, we are creating the year-wise partition by year. If you will see, from 17 to 25, we are creating the partitions. That is end of the December 31st. Okay, it's done. Now we can check the partition functions by using this sys.partition functions. So partition by year we have created, that is available now. Okay, based upon the range. This is the range. Okay. Now create a partition scheme. This is the main thing, right? File groups, which we call as a file groups, including in the partition scheme. This partition scheme we are going to use in newly creating partition table. So this is the new table, G item new, and we are using partition by year, date of the data which we have used the column date of business. Okay, date of birth or date of business. Okay, let's create a newly created partition table. It's created. Now same way we need to create index for the new table, right? So existing table we have same columns in primary key, composite primary key. So same way we are going to use, but we are going to add partition by year in this primary key. Okay, that is the thing, one difference. And we are going to create a cluster index on this table, new table. Okay, it's done. Now we will insert the data. Next thing is we need to insert the data from existing table to new table. Once data is loaded, we can rename the tables. Okay. So let me insert the data now from, you can see here, item to new table. We are inserting the data. Okay. Before renaming the tables, I will show you the how the differences. Okay. Let me show you. We are filtering the data based upon new table. So data is inserted. Okay. Now let's check this query. Item new is the partitioned table. Okay. We are filtering the data based upon the 2017-001. So let's check it. CPU time. So 1000 rows it's fetched, and scan count is 1, logical reads is 146, and CPU time is 0, elapsed time is 424 milliseconds. Let's check without partition table. This is the without partition table. We can check the performance. So scan count is 9, logical reads is 14,400, and CPU time is 125, elapsed time is 418 seconds. This is the beauty, powerful large data sets. If we will partition, we can see the performance on the table while querying the data based upon the year, date of the year table. Okay, date of business, year column. Based upon the year or month, if we will filter the data, it will directly go to that partition, it will fetch the data. Okay, that is the beauty we have. Okay, now let's go ahead and rename it. So how many rows we have in the partitions? We can check this by using this query. We can verify the partition level rows, how many rows we have. Okay, see how many rows we have, we can check those things. Okay, now we can rename existing table as a backup, BKP, right? So we don't want that. So newly partitioned table should be original table, G item, right? We are going to rename that. So we did that. Now let's go ahead and check this. In this session, scan count is 9 and logical reads is 400. So it should, now it is a partition table. It should reduce now. CPU time lapse like 125 to 0 seconds. Let's check that. Okay. See, this is the partition table. Scan count is reduced, logical reads reduced, and CPU time 16 milliseconds, and elapsed time is this one. Okay. Let's check the BKP table, which we took existing table as a BKP backup. Let's check this. So here you can see scan count is 9, logical reads is 14,400. Okay, so CPU time is 359, elapsed time is 503. Okay, so this is the way we can do the horizontal partitioning on the table, and we can reduce the time on that particular table. This is the best way to tune the large data set tables. Okay, I hope this is helpful for real-time environment. So if you like the video, please like it and share it to your friends, and if you have any doubts, comment it in commenting section. I will guide you the steps if you have any doubts. So please share it to your friends, and yep, that's it. Thank you so much. Bye bye.